Solve the absolute value inequality and graph the solution. Absolute value of x plus 5 is less than or equal to 7. Now with absolute value inequalities, we're going to have two inequalities to solve. The first one, which we'll call the positive inequality, is exactly what's written but without the inequality signs. What we'll call the negative inequality is exactly what's written, but we'll flip the inequality sign so that it faces the opposite direction and change the sign of the answer. So the reason that we do this, the reason we have two equations, is if you think about it, absolute value always makes a number positive. So for example, the absolute value of negative 6 is equal to 6, and the absolute value of positive 6 is also equal to 6. So because absolute value returns a positive value for both a negative input, like negative 6, and a positive input, like positive 6, that's why we have this situation of having a positive and a negative equation when we're solving the inequalities. One time that we would not set up both a positive and negative equation is if we had less than or equal to negative 7 or less than or equal to negative 5, some negative number outside of the inequality. Then the inequality would be impossible to solve. But in this case, since we have a positive 7, we can solve both of these equations independently. So the positive equation we would solve by subtracting 5 from both sides, and we'd get x is less than or equal to 2. The negative equation, subtract 5 from both sides, and we get that x is greater than or equal to negative 12. We're going to put both of these inequalities on the number line. X less than or equal to 2 looks like this, shading everything to the left of 2. And x greater than or equal to negative 12 means all of the numbers greater than negative 12, so we shade to the right of negative 12. Now with this solution set, our solution is all of the values between negative 12 and 2. The way that we'll write that as an interval is negative 12, 2. So with this type of inequality where we have less than or equal to a number, we'll be treating these two separate inequalities as an AND inequality, and that means that we want the overlap of their shaded regions. Example 2, solve and graph the absolute value inequality. Absolute value of 2x plus 3 is greater than or equal to 13. We'll set up the positive equation, which is exactly what's written there without the absolute value signs. 2x plus 3 is greater than or equal to 13. And then the negative equation, 2x plus 3, flip the inequality so that it says less than or equal to, and change the number to negative. And then we'll solve both of these independently. Subtract 3 from both sides, and we get 2x greater than or equal to 10. Divide by 2, and x is greater than or equal to 5. On the number line, we'll put 5. X greater than or equal to means shade to the right of 5. Now the second inequality, subtract 3 from both sides. 2x is less than or equal to negative 16. Divide by 2, and x is less than or equal to negative 8. On the number line, we would shade to the left of negative 8. See, with this type of inequality, our shaded regions point away from each other. That is because this time we started with a greater than or equal to sign, which means that here we're treating these two inequalities as if it is an OR inequality, so only one of them needs to happen. That means that this shaded region, the way that we're going to write it as an interval, is representing both of the regions. So from negative infinity till negative 8, and also from 5 until positive infinity. This U symbol is union, which means or. So either negative infinity to negative 8 or 5 to infinity are the possible regions for solutions to this absolute value inequality.